Welcome everyone. Today we are going to look into the block elements. We all know that the elements have been classified into four different blocks, that is S block, P block, D block and F block. Here we are going to study in detail about the P block elements. What are P block elements? P block elements is that the last electron of all these elements enters the outermost P subshell. Moreover, the 13th group element, 13th to 18th group element are termed as P block elements, as its electronic configuration ends in P block, P shell. Usually they are good conductors of electricity. P block elements have a shiny luster. Gallium, a P block metal that can actually melt at your arms. On the other hand, P block elements also have silicon that is a metalloid. It is a very important component in making of glass. P block elements comprise of the various families that include boron family, nitrogen, oxygen, fluorine and neon. Thus we see that P block starts from 13th group and goes to 18th group in the periodic table. We will be talking about the nitrogen family, as boron family we have already learned in grade 11th. So which all elements are present in the nitrogen family? Group 15th elements that are also termed as nitrogen family. The elements of group 15 includes nitrogen, phosphorus, arsenic, antimony and bismuth, which belongs to the configuration is Ns2Np3. Atomic and ionic radii of these nitrogen family, that is, covalent and ionic radii increases down the group. As we move down the group, the size of the atom increases with increase in its atomic radius and atomic number. Therefore, covalent and ionic radii increases. There is an appreciable increase in covalent radii from nitrogen to phosphorus, small increase from arsenic to bismuth due to the presence of completely filled d or f orbitals in the heavy elements. What can we say about ionization energy? Ionization energy is the energy that is required to remove an electron from the outermost shell to obtain a positive ion from the neutral gaseous atom. Hence, in nitrogen family, ionization energy goes on decreasing down the group due to increase in atomic size. Group 15 elements have higher ionization energy than group 14 elements due to smaller size of group 15 elements. Group 15 elements have higher ionization energy than group 16 elements because they have stable electronic configuration, which is half-filled p orbitals. So this, whenever on the basis of ionization energy, number of times the questions are asked. So kindly be careful whenever ionization energy type of question is asked, kindly get into the electronic configuration. Electronegativity. The electronegativity value decreases down the group with increase in atomic size. As electronegativity is defined, the element attracts the shared pair of electron towards itself. So more the attraction power, more is the electronegativity. This gain is due to the increasing distance between the nucleus and the valence shell as we move down the group. Physical property of group 30 nitrogen family elements are all the elements of group exist in a polyatomic state. Nitrogen is the gas, which is the first element of this nitrogen family group. But as you move down, there is a significant increase in the metallic character of the elements. Nitrogen and phosphorus are nonmetals, arsenic and antimony are metalloids, and bismuth is a metal. These changes can be attributed to the decrease in ionization enthalpy and increase in atomic size. Boiling points also, in general, show an increasing trend as you move down. Except for nitrogen, all the other elements have allotropes. Now, what is an allotrope? Allotrope means an element having same constituent but different physical properties. For example, if we take an example of carbon, the allotropes of carbon are diamond, graphite, fullerene that we have already learned in our lower grades. Chemical property. The valence shells of the p block elements have a configuration of ns2np3. That means having 5 electrons in the outermost shell, which shows that this belongs to the 15th group element. So the elements here can either lose 5 electrons to attain octet configuration or gain 3 electrons to attain octet configuration. Therefore, the common oxidation state of these elements are -3, +3, and +5. With a decrease in the ionization enthalpy and electronegativity due to the increasing atomic radius, the tendency to gain 3 electrons to create a -3 oxidation state decreases down the group. In fact, bismuth hardly forms any compounds with -3 oxidation state. As we go down, the stability of the +5 state decreases. I repeat, the stability of the +5 state decreases and that of +3 state increases due to inert pair effect. These group elements also form hydrides, which is the type of MH3. M is metal, H is hydrogen over here. The basic strength of the hydrides is as follows. That is, as we go down the group, the basicity of the hydrides decreases. Hence, the highest strong basic hydride is ammonia. The thermal stability of the hydrides also decreases as the atomic size increases. That means the thermal stability will decrease as you go down the group. Nitrogen cannot form NX5 because of non-availability of d orbitals, whereas bismuth cannot form a BiX5 because of reluctance of 6s electrons of Bi to participate in bond formation. Rest of phosphorus can also form PX5. We have seen the example PCl5. Nitrogen forms a number of oxides. The rest of the members of the group form only two types of oxides. That is E2O3 means P2O3 and P2O5, where E is kept as in general for phosphorus, arsenic, antimony, and bismuth. Next comes oxygen family. Let's see which all members are present in the oxygen family. Oxygen family is also known as chalcogens as it is just before the halogens. This is group 16 elements. Oxygen family comes under the group 16 elements of the periodic table. Hence, oxygen, sulfur, selenium, tellurium, and polonium are the family members of oxygen family. Its electronic configuration is Ns2 and B4. The first element of group 16 differ in its chemical behavior from that of other members of the group due to its small size and high electronegativity. Because oxygen is the first element, so oxygen is highly electronegative element than rest of the element present in the oxygen family. If we talk about the metallic character of oxygen family, the metallic character increases with increase in atomic number. The first four elements are non-metallic in character. Non-metallic character is strongest in oxygen and sulfur, weaker in selenium and tellurium, while polonium is metallic in nature. When we talk about atomic and ionic radii of oxygen family, atomic and ionic radii increases from top to bottom due to increase in the number of shells. As this is the trend of the group elements, as we go down the group, the outermost shell have same number of electrons, but as we go down, the number of shells increases, which which increase the atomic size. Oxygen has less negative electron gain enthalpy than sulfur due to compact nature of oxygen atom. Ionization energy decreases down the group due to increase in atomic size. Elements of group 16 have lower ionization energy values as compared to group 15 in the corresponding periods, as group 15 elements have half-filled p orbital. Now, as per our studies, it shows the orbitals that are half-filled or completely filled. They have high stability. Hence, ionization energy of group 16th elements have lower values than the group 15 elements. Next to fluorine, oxygen has highest electronegativity value amongst the elements. Within the group, electronegativity decreases with increase in atomic number. The tendency of catenation decreases as we go down the group. What is catenation? Catenation means linking of the atom in a long chain. That is the reason why carbon compounds, right, are available in nature because carbon can form n number of bonds with a long chain. Similarly, in this oxygen family is also having the tendency for catenation, but the tendency decreases as we go down the group. All the elements of the group form volatile hydrides. What does mean by volatile? The one which can evaporate easily at room temperature. Hence, group 16th elements forms volatile hydrides. The volatility increases from hydrogen oxide to hydrogen sulfide and then it declines. This is evident in their boiling point. Increasing order of boiling points of hydrides is as follows. The thermal stability of the hydrides decreases in the order as we go down the group. The strength of the hydrides is acid increasing in the order. That means as we go down the group, the strength of the hydrides of group 16 elements increases. Chalcogenes also form compounds with halogens known as chalcohalides. All the elements of group 16 form binary halides. For example, selenium chloride also are known to exist. T2Cl2 and T2Br2 form polymers when in the solid state. Oxoacids. What are oxoacids? An oxoacid is a compound whose molecule contains at least one hydroxyl group bonded to an atom that in turn is doubly bonded to at least one oxygen atom. Here are few examples given to understand in a more better way what are oxoacids. Sulfur, selenium, and tellurium form a number of oxoacids. Among the oxoacids of sulfur, sulfuric acid is most important. Sulfurous acid, thiosulfuric acid are unstable and cannot be isolated. They exist only in aqueous solutions or in the form of their salts. Fluorine family, which is also known as halogens. These are the 17th group elements. Its electronic configuration is Ns2np5. The family members of fluorine family are fluorine itself, chlorine, bromine, iodine, and astatine. As you see, as we go down the group, the volatility increases. Solid directly converted into the gas. Iodine is one of such example, that is the sublimable substance. Fluorine found in toothpaste, non-stick utensils, right? That is Teflon. Fluorine is useful in forming compounds with the noble gases. Chlorine, you can see it is used as in germ-free tablets. Bromine is an irritating gas. Iodine, you can see it's a sublimable substance, and astatine is a radioactive element. Halogens have the smallest atomic radii in their respective periods due to maximum effective nuclear change. The first ionization energies are relatively high but decreases down the group. Iodine can lose an electron and form I plus ion. Electron affinity varies as chlorine greater than fluorine greater than bromine greater than iodine. Fluorine is the most electronegative element known. Electronegativity decreases down the group. In group 17th element, halogens are good oxidizing agents and the oxidizing power decreases down the group. So basically in a given chemical reactions, you will be able to see that chlorine gas is acting as an oxidizing agent. Now oxidizing agent itself undergoes reduction as it helps in oxidation. Reactivity varies as F2 greater than Cl2 greater than Br2 and greater than I2. Order of ionic character in MX bond is MF greater than MCl greater than MBr greater than Mi. As you go down the group, the atomic size increases and the ionic character matters in this manner. Strength of hydrohalic acid varies as HF less than HCl less than HBr less than HI. And the order of boiling point is that is HF is having the highest boiling point amongst all hydrohalic acids. As F is very small size, they form a short bond which is a strong bond. We have already talked about the bond length that lesser the bond length, stronger is the bond. And stronger is the bond, so more energy is required to break the bond. Hydrohalous acids are all weak acids and exist in solution only. The strength of hypohalous acid, the acidic strength decreases down the group, that is HOCl greater than HOBr greater than HOI. Acidic strength increases as the number of oxygen atoms increases for a given halogen atom. It follows like this: with more of oxygen atom, the acidic strength increases. Now, these reactivity series are very, very important. Neon family, the 18th group elements, it is also known as noble gases, inert gases, as they do not exchange their electrons. Let's see the family members of the neon group family, that is helium. Though helium is having only two electrons, right, it comes under the 18th group elements because of its property. It is attaining a stable electronic configurations, and that is the reason why helium is placed under the 18th group elements. So helium, krypton, argon, neon, xenon, these all are the family members of neon family. We can see the daily life usage of these noble gases. So helium, it is used in balloons float, the gas balloons that we love to uh, right, blow it in the air during Uttarayan. Maximum times we do so, right? So balloons float and helium is present into it. Helium is also used to cool superconducting magnets in MRI scanners. It is also used to condense hydrogen oxygen to make rocket fuel. Krypton is used in medicines, light bulbs, neon sign bulbs, and as well as in lasers that is used in space. Argons are used in incandescent bulb or lamp. Neon lamps are considered one of the 12 main types of electric lamp. Inhalation of concentrated neon can cause dizziness, nausea, vomiting, and loss of consciousness. Lamp filled with neon can only make red light. Even xenon is also used as an in incandescent lamp. Xenon can also react with fluorine to form many different compounds. Noble gases are located at the end of each period. Their valence shell orbitals are fully occupied. They are monoatomic and are sparingly soluble in water. Xenon forms chlorides of type XeF2, XeF4, and XeF6. Xenon trioxide or xenon oxide, that is XeO3, is trigonal pyramidal in shape, whereas xenon oxyfluoride is square pyramidal. Uses of noble gases, that is helium is a non-inflammable gas, lighter than air, therefore used in filling balloons for meteorological observations. Here you can see the procedure how it is useful as and meteorological observations. The picture is given just right to you on the slide. Argon is used to provide an inert atmosphere. This is a periodic table with the all elements and their usefulness. You can see the pictures, right? The particular element is used for constructions of those things that are been given in the picture. So just go through it and have a basic idea that we have so many elements in the periodic table and how it is useful in our everyday life. Thank you. Have a nice day. Stay safe, stay healthy.